Mi presento, mi chiamo Bernard Conzet, sono della MARPOSS, che è una società che si occupa di sistemi di controllo in produzione e con sistemi di elaborazione dei dati, di questi dati che prendiamo all'interno dei nostri, attraverso i nostri sistemi. E abbiamo messo come titolo Giving More Value. Scusate, io sono passato in italiano, però in teoria volevo farlo in inglese. Let's go ahead in English because it's better for the transmission. Sorry, I was changing language. So the idea was giving more value to measure, because I think we all agree that with the new technologies that we have now available, a lot of things are changed in measurement. We have the possibility to measure with high frequency, we have the possibility to measure in continuous, we have the possibility to elaborate the data, we have the possibility to measure 24 hours for 24 hours. So this means we have a tremendous space of improvement in the quality measurement, in the quality assurance that we think that we can elevate with all these technologies. Just to give a little bit the scenarios of the development the last years and put it on the line of the industry evolution. So we speak about the second industry revolution. We measured, before even measuring was not done, but then when we start measuring, we also start to register the measurement. Normally it was paperwork. But immediately as we start with paperwork, in the 60s, there were some types of statistical elaboration, which was very, very simple, because it was very important to have a statistic that was possible to do also on a simple paper. So, and to explain it in a simple way to the operator who was collecting this data. In the third step, we already went ahead with paperwork, and honestly speaking, also today there are still a lot of production where we have paper. But we introduced the computer in the production. This gave us the possibility to make calculation immediately, which gives us also the possibility to use some more complex statistical elaborations. We had the possibility to measure, to store this data in the network, and we had the possibility to distribute this data. But normally it was made in local networking. Now the scenarios changed, not everywhere, because still today we have a lot of companies where the data are registered on paper, which is really a pity to do that, because there is no possibility to do anything with this data. So it's really poor documentation. We have data collection PCs, so we have the possibility, not only PCs, we have sensors, we have a lot of different possibilities to collect this data. We can collect this data also from sensors that are inside the machine. So we have a continuous data collection. We have the network, we have the analytics. Now we have also the possibility to use very, very sophisticated analytics. We have the possibility to integrate this data with all the other data of the company and to integrate different parameters. We will speak about that after. So we have enormous potential of analyzing this data and to improve our productivity and our quality. So some keywords about the change from Industry 3 to Industry 4. Maybe there is one interesting point that let's say I want to point out two things. One is cost-benefit assessment. In the past, or till today, we tried to measure as less as possible or as much as necessary, because measuring was a cost, because you had to take the parts and so on and so on. Now, more and more, we have the possibility to measure inside the process. We have the possibility to use very, very fast measurement with opticals and so on and so on. So it's not true anymore to say, if I measure, I increase my cost. If I measure one or if I measure all the parts, it's not a big difference. So we can afford to collect all the measurement data. If we speak about statistical process control, there is a big difference now. When we speak about statistical process control, SPC, and maybe you know this type of technology, there is a very interesting point. Normally, we were on the idea to have a stable process and to have a statistical process. We have a statistical distribution. But with the machines, with autocorrection, with very, very small lots, and so on, we even more and more, we are in trouble with this, because the machine is correcting itself, so we don't have a normal distribution or some type of distribution. We change very often our parts, so we don't have even the time to understand if a process is stable or not stable. In the Industry 4.0, this situation becomes stronger and stronger. But we have new technologies with artificial intelligence, with machine learning, that give us the possibility to take advantage of this situation. So this is the direction we develop all our products in MARPOSS, and we call that MARPOSS Digital Platform. One very important point for us is speaking about the competences. So on the left-hand side, you see the paradigm from Alex Salze, who speaks about the T and the phi. This is just to explain that normally every scientist who has knowledge in a special area has to use also computer and statistical knowledge. So if we speak about big data, if we speak about information technology, if we speak about digital transformation, digital revolution, any person who has to do with something where we can collect the data needs to have the competences. And this is one point where MARPOSS is very, very strong, because we have in MARPOSS, we have the domain competence. MARPOSS is working with the machines since all the time. So we know very, very good the production process. We know very, very well your products. We know very well the machines. We know very, very well the measure process. So on the domain expertise, for sure, we are very, very strong. We have historically, and we add people in mathematics and statistical competence, because the models are quite different. It's not the same models that we had with an SPC system. It's quite different, and I will explain in some words afterward. Then we need the computer skill, because these data are not clean. They are not perfect. So we have to clean this data. We have to collect this data. We have to distribute this data. We have to store this data. There's a lot of additional points that we have to think about. I just showed here the danger zone. The danger zone is just to underline, if you have computer skill and if you have domain skill, but you don't have a very good statistical skill, what is the risk? What we see when we applicate certain algorithms of artificial intelligence or machine learning, you have to see there is a lot of parameters that you can play with. If you don't play correctly with these parameters, the risk is that you have a statement, that you have an information, but this information is not correct. So to understand if the information that comes out from the system that is using machine learning or artificial intelligence is correct, you need all of these competences. Maybe not in one person, maybe you have 2 persons or 3 persons, you're working a team, but it's very, very important to have all of these competences. And we in MARPOSS, we are very aware of that. Let's say one strong point is that we have a lot of domain competence. This is a very simple example, but it's just to explain how it's working a machine learning model. You have input data. You have data that you already know what type of data they are. And with this, you start to train your model. Then, if the model is trained, at a certain point, you get a picture, you get an information, you get a curve, you get something, and you are able to say, okay, this is from this point or is from this point. The problem here is, and this is still a big problem in the Industry 4.0 scenario, that normally you need a lot of data. Because if you don't have enough data to train the model is not very precise. But having very, very small lots brings this type of problem. And I just want to give you this signal. This is important that you are aware of that. Another point is, and something what we are working a lot on, the integration. So the vertical integration is something that for us is clear. Okay, there is the machine, there is a sensor, there is a machine, there is a department, and so on and so on. But more and more and more, we integrate also external parts. So we get data from our customers because we have intelligent products. These intelligent products generate data. They bring them back to the supplier, and the supplier has to elaborate this data together with his data in the production. So it's very important to be in contact with your customers and your suppliers. Also, your suppliers have to be able to receive data from you to improve their processes and give you back data that gives you the possibility to improve your process or to predict certain problems that comes from the data of your supplier. So we have a horizontal and we have a vertical integration. Both is very, very important. This just to give a scheme of what we are doing in Marpos. You know, we have if you look on the left-hand side, you see the DNC, the machines. We have condition monitoring with Marpos monitoring system. So we are working on the machines, having sensors inside the machines. And if you come on our stand, we can show you that. We take this information. This was in the past just to protect the machine. Now we have a lot of data that give us the possibility to understand the status of this machine. And this gives the possibility to do predictive maintenance, but not the simple predictive maintenance that we speak about, the temperature of a fuse is going higher or something like that. We can have a lot of parameters and we can correlate them. What I always speak about is about the not evident correlation. This is a very important point. On the other side, we have all our area of measurement and of testing, where we measure the parts, we test the final parts, and so on, and we have a system for quality management and compliance management, which gives us the possibility to take this data to define the improvement. You have the non-conformities, you have the corrective actions, you have the preventive actions, you have the lessons learned, you integrate all this data with the ERP, with the PLM, and so on and so on. So we can give a complete system from production, from measurement, from testing, and from compliance management. So thanks to our technologies and expertise, what do we have? We have the data in a centralized database, and we have applications that are web-based. This means I can have this data anywhere and in any moment. I can access this data. I can use technologies where I can find algorithms that are available in the cloud. So it's not necessary that Marpos or you develop all these things, all this knowledge, and so on and so on. There are things that we can find directly in the cloud. Sure, we need, as we said before, the competence of all this area. We have to know about the domain, we have to know about statistics, we have to know about computer technology. What I showed in the graphic on the left side maybe is a little bit technical, but I wanted to show a difference between precision and recall. What is the problem? If I have a model which is very precise, where I can say, okay, it is sure that all the true positives that I have in my population, I will get them. There is a risk that I get the true positives, but not all of them. At the moment, when I move to have all the true positives, automatically the risk that I have some false positive is increasing. So we have, with our parameters, we have to play, and we have to decide if we are more interested on precision or we are more interested on finding all the phenomena we are looking for. So this is a curve that has to be optimized in our view of all our process. So at the end, what is Marpos? We have measurement, testing, and monitoring, which is our traditional business. We work since 20 years in data collection, and we invest now a lot in data sharing, because in the past it was more local elaboration. Now we have a distributed elaboration. We have the data analysis, and we go to prediction. I always say, don't look only on prediction, look also on data analysis, because just to understand what you are doing is a very, very high value. Then we combine this with the quality compliance management, so to have a complete process to a total quality management system. Thank you.